S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Welcome to S. Chand Academy, and I am Dr. Anmol Bhatia. We are covering the course Applied Thermodynamics, and in that the topic of this video is air compressors. Students generally confuse with the compressors and pumps. So that confusion will be covered in this video.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
The topic is air compressor, and it's a part of the syllabus Applied Thermodynamics. So if we go as per the definition, a compressor is particularly a device that takes definite quantity of fluid. Generally in our situation it is usually the gas, but often we use air in compressors, and basically it delivers that particular air at the required pressure. So in short, what happens, it takes the atmospheric air, it compresses it, and it delivers it to the it delivers it to a storage vessel. And this compressor basically requires work to be done on the gas, and compressor must be driven by some external or you can say some sort of a prime mover, and that prime mover is basically an engine in our situation. So the thing that is generally confusing is what is the basic difference between a compressor and a pump. So the major difference is the compressor handles the gases and pumps handles the fluids. So the gases basically, as you know, that the gases are compressible, and it reduces the volume of the gas. So this compressor basically reduces the volume of gas, and liquids are generally incompressible. So while some of the liquids can be compressed, so in general scenario this is a basic difference, that air is generally used in case of a compressor, and liquid or fluid is generally used in case of the pumps. Now there are certain application areas in which these compressors are used nowadays. Let's say the first one is in the air conditioners. Compressors are majorly used, be it the home air conditioner or the car air conditioners. There are certain pneumatic devices in which this compressed air is being required. So the application area is the pneumatic device, and in refrigerators also, be it the domestic one or be it the industrial one, these compressors are used. It is also used for the hydraulic machines, and air compressors are basically used for industrial manufacturing. There are certain application areas like in abrasive jet machining, or in case of the machining aspect, there are some areas in which these compressors are used, and the compressed airs can be used or can be produced with the help of these air compressors. Now, how do we classify the compressor? So compressor can be classified into two terms. One is related to the positive displacement, and another is the dynamic kind of compressor. So if I talk about the positive displacement category, there are rotary compressors, or you can say the reciprocating compressors. And if I talk about the dynamic category, there are centrifugal or axial compressors. In case of rotary compressors, we have certain categorization like lobe type, screw, liquid ring or scroll or vane categorization, and in reciprocating we have diaphragm type, double acting and single acting type of reciprocating devices. If I talk about the general syllabus as per the AICT model, the syllabus says that you have to study about the reciprocating type of compressors. So we will be dealing about reciprocating compressors in detail, and in brief we will be studying about the rotary compressors. So basically the dynamic compressor is basically that category that continuous, that is there responsible for the continuous flow, and it is characterized by the rotating impeller, and that rotating impeller adds velocity and pressure to the particular fluid. So if you want to add velocity, or if you want to increase the velocity or pressure of a particular fluid, then we need to use this dynamic compressor. And it is widely used in chemical and petroleum refineries, and these categorizations are of the dynamic compressors, namely centrifugal compressor and the axial flow compressor. Now if I talk about the centrifugal compressor, so centrifugal, as the name suggests, that it acquires this compression, or it achieves this compression by applying certain inertial forces to the gas, and by the means of that rotating impeller. So it has a rotating impeller in which you can say the inertial forces of the gases are responsible for creating that particular compression of that air. And if I talk about these categorizations, it is usually a multi-stage type compressor, and each stage consists of an impeller, as the rotating element and the stationary element are there. So there are two different stages, there are multiple stages of events that would be occurring, and at each stage the impeller would be used, and there are rotating elements and a stationary element in there. So you can see that the compressor will discharge certain amount, and there is a compressor casing which is there in the front. So what happens, fluid flows, enters into the compressor axially, and discharge is in the radial manner. So the entry of the fluid is in the axial manner, that is towards the axis, and towards the radius it moves particularly outside. Herein it particularly loses the velocity and it increases the pressure, which is particularly required in case of a compressor. Then you have another category of this dynamic compressor, which is the axial flow. In this, what you can say that the working fluid principally flows parallel to the axis of rotation. So this example is of the axial flow, in which the working fluid flows parallel to the axis of rotation. That means that, let's say, this would be the axis of rotation on which it rotates, and the working fluid majorly moves in the direction which is parallel to the axis. And if I talk about energy levels of the air or the gas flowing, that energy level can be increased by the action of the rotor blades. So there are rotor blades which are continuously moving inside, and it basically exerts torque on the fluid. Because of that, the energy levels are increased. And next, it has benefits of high efficiency, and the mass flow rate is larger, and it requires several rows of airfoils. And why that airfoils are required? In order to increase a rise in particular pressure, and thereby making it complex and expensive for a particular operation. So this is as far as this axial flow compressor is concerned. So I have talked about the previous category. Now this is another category which is related to the positive type displacement compressor. So positive displacement type compressors, basically they causes movement by trapping a fixed amount of air and then forcing that trapped volume into the discharge pipe. So it captures that particular fixed volume and forces that particular volume into the discharge pipe. So categorization, it basically consists of two categories, one which is the rotary compressor, and the second one is a reciprocating compressor. So these two categories are the categories in which we are particularly interested in. To note down the particular aspect of these two categorizations. So we stop here for a short break. After coming back from the break, we will learn the details of rotary compressors and reciprocating compressors.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy after the break. I am Dr. Anmol Bhatia, and we are doing the course applied thermodynamics. The topic that we are covering in this video is air compressors, and so far we have seen the categorization of air compressors. Now in this part of the video we will be learning the details of rotary compressors and the reciprocating compressors. So if I talk about the categorization of the positive displacement type air compressors, we have two categories that we have seen before going to the break. So what are those categories? The two categories are reciprocating type air compressor and the rotary type air compressors. In this you can see that it has a piston, it has a cylinder arrangement. So it has a piston again, it has a cylinder arrangement, and the air is being entrapped into the particular gap of the cylinder, and it causes a compression and the air gets compressed. And in case of a rotary compressor, the air is moving inside, and it particularly is rotated with the help of the wheel which is sliding over the surface, and it compresses that particular air, and the compressed air moves out from that particular chamber. Here also the compressed air moves out from the particular chamber. But if I talk about the further sub-categorization of the reciprocating type case, so it has number of stages. Number 1 is the single stage categorization, and number 2 is a multi-stage categorization. If I talk about the number of sides of the piston in operation, so if it is single acting, then it is called as single acting reciprocating type compressor, and if it is double acting, it is known as the double acting type reciprocating compressor. We'll see more details of these in the forthcoming slides. Now before coming to the reciprocating compressor, let us have a general discussion, a clarity on the rotary compressors. So as I have told you that the air moves inside that particular chamber, then it gets compressed, and the compressed air moves out of the particular exhaust valve. But what happens inside? Let us see. The gas is compressed by the rotary action of the roller inside the cylinder. So there is a roller impeller which is there. So you can see that there is a roller, and there are refrigerant vapors inside these gaps. So what happens? The roller rotates off center a shaft. Off center means it is not rotating as per the axis. So it is rotating in a manner like as it is shown in the diagram, that it moves off from the center, so that the part of the roller which is always in contact with the cylinder. So there is one particular sort which is always there in contact with the cylinder. So the volume which is occupied inside the cylinder is reduced. So you can see, as per the diagrammatic presentation, the volume is reduced and the refrigerant gets compressed. So you can see that whenever it moves in this particular side, the volume is reduced and the refrigerant gets compressed, and whenever it moves out from this particular scenario, then the air gets compressed in the particular manner. So it is basically highly efficient, as this sucking and compressing action of the refrigerant, it occurs simultaneously. You can see that the refrigerant is getting inside from this intake port, and it is moving outside from the exhaust port. So these two actions are simultaneous actions, and this particular operation is treated as to be the highly efficient type of categorization of a compressor. Now the next categorization that you can see is the case of this reciprocating compressor. As I have already told you that it's a part of positive displacement type compressors. So what happens, I have told you that it has two valves, one is the intake valve, another is the exhaust valve, and the air moves inside from this particular intake valve, and what happens, the piston moves upward so that it compresses the amount of air which is there inside the cylinder. After it gets compressed, the intake port closes and the exhaust valve intake valve closes and the exhaust valve opens, and the compressed air moves out from that particular valve. So you can see that it uses a piston driven crankshaft to deliver the gases at high pressure. So there is a crankshaft which is below, and piston is connected to that particular crankshaft. As I have told you that the intake gas enters the suction manifold. So there is this suction manifold which is beside this intake valve, and the gas moves inside the cylinder through the help of this suction, or you can say the intake valve, and then it flows into the compression into flows into the state of, you can say, the compressed one into the particular cylinder, and it gets compressed by the piston which is there in the reciprocating motion. So piston moves upward, like it moves inside in a reciprocating manner, and it compresses the volume of air which is there inside this particular cylinder. Now the air which is discharged to the atmosphere, that air is at a high pressure because this gets compressed. So two operations, one is the rotary, another is the reciprocating. In the rotary, the moving impeller moves in the off radius type manner, so that it compresses the amount of air which is present inside. Whereas in case of a reciprocating cylinder arrangement, it is being compressed, or reduction in the volume is there with the help of that piston. So this is the basic difference between the rotary and the reciprocating type of categorization. Now we would be talking about different stages of the reciprocating type compressors, and there are certain mathematical derivations and certain formulas involved in the reciprocating type of compressors. So we will be understanding it with the help of the PV diagram. So what happens, prior to going towards the break, we have talked about certain cases like multi-stage or the single stage, and then with intercooling, without intercooling. So I will be telling you about that particular processes, and we will be deriving them one by one. So you can see that there are the cases of pressure and volume diagram inside this reciprocating cylinder. So you can see that it starts from this region 1, it moves to 2, and then the 3 region is there. Then simultaneously it goes into the 5 region, then 4 region, then again come back. So this is particularly a particular region that we would be interested in. And there are two categorization, one which is the low pressure type value, another is the high pressure type value. So when you can see that intercooling is not there and low pressure type value or high pressure type values are there. So we will be moving from 8 to 1, then towards this 4 and then 7. So this region is indicated by a low pressure region, and apart from that, this particular region which is from 7 to 4 to 5 to 6, this particular region is called as the high pressure region. And whenever you can see that there is intercooling, so the same process goes along, like 8 to 1 to 4 to 7, the same process is there in case of intercooling as well, but the pressure is low. Wherein when the pressure becomes high, so it changes the state from 7 to 2, then 3 to 6. So these two, one is this which is there with intercooling, and second when we use, when this particular area gets covered when there is no intercooling. So it is being depicted in the diagram also. When there is a perfect intercooling is there, so you have this particular cross section. Without intercooling, you have this particular cross section. And when the gap and when the simultaneously difference between the two occurs, then you can see that there is a shaded region. So there is a shaded region, particularly it is there, and that shaded region occupies this particular equation, which is PV raised to the power n equals to C. These regions are related to the delivery pressures, these are intermediate pressures, and this one is the intake pressure. So this is the case of diagram explanation. Now we will be coming to that derivation part. So whenever there is a multi-stage compressors means that we are moving from one stage to another, and it has n number of stages. So we would be interested in this 8156. So 8156 is the total particular value of the total area which is being covered, and this diagram is a PV diagram, and we would be interested in finding out the work done. So work done here will be related to this particular formula n over n minus 1 P1 V1, and additionally the two pressures which are there, which is pressure number 5 and pressure number 1. So we would be interested in getting those two pressures together. So that would be P5 by P1 raised to the power n minus 1, and the delivery temperature can be determined from this particular expression, which is T5 equals to T1 P5 by P1 raised to the power n minus 1 over n. That is particularly for the process that follows PV raised to the power n equals to C. Then there is a case of a two-stage compressor in which the two categorizations are there, with intercooling and without intercooling, that we have already discussed. And for this, when the two stages are there, so there would be two pressures involved, one which would be P4 and P1, another which would be P5 and P4. So one is particularly for this region and second is particularly for this region. So this remains the same, the formula for work done remains the same, P1 V1, P4 by P1 raised to the power n minus 1 by n, P5 by P4 raised to the power n minus 1 by n. So the same thing is there for you can say without intercooling aspect also. Now for you can say the perfect intercooling, which is this internal region, in which there are cases. For the first case 81478 the first case, and the second case is 7, 2, 3 and 6, 7, 2, 3, 6, 7, this one, this internal region. Earlier when there was no intercooling, the total region was covered. Now for perfect intercooling, the internal region was covered. So herein also you will have two different segments of the equation, and P1 V1 is already there as stated in the previous cases, but P4 and P1 would play a role, and n minus 1 by n is a general equation for the same, which follows this PV raised to the power n equals to C. And for the next case you have this P3 and P2. So P3 value and P2 value, but prior to the previous case it had 5 and 4, because we would be looking the case for the overall aspect without intercooling. So this is the case, and temperatures can be determined from there, and you can see that the temperature 2 value would be same as that of temperature 1 at there is a perfect intercooling case. And then if it is a two-stage compressor and there is a perfect intercooling, then again you have this particular representation in which temperatures remains the same. So P2 V2 equals to P1 V1, and also P4 and P2 would be the same, would be having the same value. So temperature 1 and temperature 2 would be having the same value, and pressure 4 and pressure 2 would be having the same value, as you can see in the diagram. So the ultimate expression that would be there is this expression, and this particularly is for the shaded region, which is 2, 4, 3 and 5. 2, 4, 3, 5 and 2, this particular region, in which we subtracted the two relationships that we got in the previous cases. Now there is a condition for the minimum work. For maximum minima, you have to know that the derivative of the work done value would be determined, and we need to put that derivative value equals to 0. In the similar manner we will be proceeding for this. So we got an expression of this particular shaded region, which is this expression, and now our agenda is to derivate it and put it equals to 0 for the constant pressure part, which is this P2 value. So we will be deriving it with respect to P2. So after derivating it and applying the general rules, like the first rules for the derivative, when we apply, we'll get, or we'll come across this particular expression, which would be the final expression here. So that particularly indicates that the ratio of the pressures, which is P2 over P1 and P3 over P2, that proportion or that ratio remains the same. This is particularly for the case of the air compressor, and that category is the reciprocating type. And when it is the case for intercooling, we need to put in that value in that final expression which we got. After getting that, putting that final expression, we will get this work, and that work would be the case for the shaded region that indicates minimum value. So with this, we come to the end of the video, in which we learned about the difference between the rotary and the reciprocating compressors, and we had a look on several aspects of the reciprocating compressors with the help of derivations. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.